When you first encounter raw code, it rarely presents itself as a tool you can use. It looks like shifting static, a high-speed system reserved for people whose minds are pre-wired for this kind of complexity. This feeling of being overwhelmed is a natural biological response to high information density. When we see 100 unknown variables at once, the brain struggles to find an entry point. It is the same cognitive friction you feel when trying to balance, steer, and pedal a bicycle for the very first time. Confusion in this moment is not a lack of capability. It is the result of looking at a finished, complex system without seeing the individual observations that built it. Python acts as a bridge between human reasoning and machine execution. It allows you to take a thought and state it with enough precision that a computer can carry it out. We navigate this by returning to first principles. We ignore the complexity of the whole system and focus on one manageable rung at a time. This begins with translation. You take a vague human objective and break it into smaller, solvable parts. Programming is the act of clarifying your intent. Before a single line is written, you have to define the relationship between the information you have and the result you want. Progress comes from understanding these relationships, rather than attempting to memorize an entire library of technical commands. Python provides the structure. It gives you a medium to express the logic you already use to navigate the world. To build a system, we start with the most basic requirement, memory. In daily life, when we need to find something again, we give it a name. This is a variable. It is a readable reference point tethered to a specific value in the computer's memory. Because the name is attached to the data, that information remains available at every step of the process. You can update the value or recall it whenever the logic requires. Once a system can remember, it can begin to evaluate. We use if-else statements to turn human judgment into executable tests. We take a factual observation, like whether a count has reached a limit, and use it to determine which path the program follows. These are the fundamental mechanics of choice. We are taking the steps of a routine decision and making them explicit enough for a machine to follow. The ability to decide leads to the ability to repeat. A loop is often viewed as a cycle, but it is the architecture of efficiency. Python returns to a task with the same patient attention every time. It performs a specific action for every item in a list, or repeats a process until a condition changes. This allows the machine to handle the high-volume, repetitive work, leaving the human mind free to analyze the results and adjust the pattern. As a project grows, the number of variables and loops increases. To keep the logic clear, a builder has to change their scale of thinking. You handle this scale by grouping related steps into distinct, self-contained units. We call these functions. A function is a named job that handles one specific part of the problem. Once you define how that job is done, you can call upon it by name whenever it's needed. This method of organization allows you to manage thousands of data points. You sort them into structured records, where every value has a place and a purpose. By following this sequence, you have moved from basic memory to building a functioning system. Programming is the formalization of this problem-solving process. You identify what to remember, how to choose a path, how to organize those steps into a repeatable structure. At this stage, your role changes. You are no longer navigating syntax. You are designing the logic that makes the syntax necessary. The code is the final expression of a plan. The intelligence of the system lives in the human intent behind those instructions. Reliable systems are not built by typing. They are built by asking questions that clarify the problem before any tools are selected. You have to determine which information is essential, what the success criteria look like, and where the potential points of failure are located. This act of framing the problem determines the effectiveness of the final program. The code can only execute the clarity of the human's original design. Without this initial clarity, even the most sophisticated commands produce results that fail to solve the actual human need. In a world where AI can generate code instantly, the value of the human builder has shifted. When instructions are abundant, the most critical skills become high-level judgment and systems thinking. An automated system can repeat a task forever, but it cannot evaluate the ethical or practical consequences of its own actions. That requires human oversight. Learning Python provides you with an operating system for your own reasoning. It allows you to organize your thoughts, test your logic, and build systems that reflect your own judgment. This is how you move past the noise and begin to build.